Hi, I'm Elizabeth with Logic Walk, and welcome to Chapter 2 of the Architecture 2 course. Today, we're taking a closer look at displays. We'll start with a quick review of what displays do, then dive into how computers use the American Standard Code for Information Exchange, or ASCII, to print characters we use every day. As we learned in Chapter 1, a display or monitor or screen shows us the output produced by a computer. We use displays to read emails, watch the news, and play video games. Behind the scenes, though, the computer follows a specific process to draw images and text on the screen. Before we review that process, let's see how the computer knows which characters to print. Computers work most efficiently with numbers. That's why we use ASCII, a system that assigns a unique number to every character. For example, instead of storing a lowercase a directly, the computer stores its corresponding ASCII number, which is 97. For a computer to print a message, it must be connected to a display. This connection might be through visible cables, like when you hook up a gaming system to a TV, or through internal connections, as in laptops and smartphones. When connected, a small portion of the computer's memory becomes accessible to the display. The computer sends messages by writing data into these memory cells. We're about to run a program that prints the name Mike. Let's break down how it works. Instructions 0 through 3 store the ASCII values into memory cells 10 through 13. Memory cell 10 contains the value 77, which is capital M. Memory cell 11 contains the value 105, which is lowercase I. Memory cell 12 contains the value 107, which is lowercase k. And memory cell 13 contains the value 101, which is lowercase e. I'd also like to point out that memory cells 10 through 25, known as the display buffer, are specifically dedicated to storing the characters that will be printed on the display. But the number of cells we actually use depends on the number of characters that need to be printed. Instruction 4 stores number 4 into memory cell 26. This cell, called the data size, tells the display to print the first 4 characters starting at cell 10. Instruction 5 stores the value 1 into memory cell 27. This cell, known as the display interrupt, signals the display that characters are ready to be printed. Let's see this process in action using the Logic Walk simulator. After cycling through instructions 0 through 3, we see the ASCII values 77, 105, 107, and 101 get stored in their corresponding cells. Next, we see that 4 is stored in cell 26. This indicates the data size. Next, 1 is stored in cell 27, which is signaling the display that the characters are ready to be printed. And finally, the program will jump back to the beginning and print Mike on the screen. But how does the computer know where to print the characters? A display is organized as a two-dimensional matrix, which consists of 40 columns by 12 rows. Each cell in this matrix holds one character, and text is printed left to right, starting at the top left corner. The display maintains a cursor to keep track of where the next character should go. The cursor is defined by two values, x, which are the horizontal positions, 0 through 39, and y, which are the vertical positions, 0 through 11. It starts at 0, 0, which is in the top left corner. As characters are printed, the x value increases. After 40 characters, the cursor moves to the next line by resetting to 0, 1. When the display reaches the bottom right corner, it scrolls the text up by one line. That is, the text in line 2 moves up to line 1, the text in line 3 moves to line 2, and so on. The top line is erased, freeing up the bottom line for new characters. The display also keeps a counter called number printed that starts at 0 and increments by 1 with each character printed. When this count matches the value in memory cell 26, the display resets the counter and is done printing. In our next lesson, we'll examine the step-by-step changes that occur during the printing process in the simulator. Take a moment to absorb all this information and get ready to see these processes in action with our simulator.